is an expert in decision automation who over his long career developed practical decision-making applications in finance, insurance, government, and many other industries. So I always try to listen Bob very attentively, because usually it's not only a well-thought opinion, but highly practical advice that I can take with me and use it in my everyday activity. Interestingly, that Bob continues to deliver more solutions to decision management community challenges that our younger colleagues, DM practitioners, and he always using the most modern technique. So that's great, Bob, and I wish you all the best. Continue to do what you're doing. And today, Bob will share with us his view on business data and how it's used to deliver good decision models.
Okay, well, hello, everybody. As I say, as Jacob says, the idea of this talk is to look at the idea of business data and how we might manage that. So in order to get started, the first thing I need to do is actually explain to you what I mean by business data. And the simplest way of doing that is to have a look at some decisions. So let's have a look at a simple rule and try and figure out what the bits and pieces are of it. So it's a very simple rule. It's saying if our applicant is under 18, then we're going to reject his application because he's too young. So we have some logic that we can see in the form that we have this if certain conditions are satisfied, then certain actions will be performed. We can see that there is some case data here, which basically represents what it is that we are trying to make a decision about. And we can see that there are some outputs, which essentially the decision that we reach through this decision-making process. But we can also see that there are some other bits and pieces hanging around here. And what are those? Well, that is what I'm referring to as the business data. Okay, that's a rule. Let's just look at a decision table to get, we can see the same sorts of components there. So in a decision table, we have some logic, which is represented by the rows of the decision table. We have the case data, which is represented by the columns of the decision table. We have our output, our decision, which is represented by the output columns of the table. And then we have these various facts sitting around in there, or these numbers, these strings sitting around, which form our business data. So that's the kind of anatomy of the sorts of decisions that we make. And if we think about how do we make decisions, then we can break down what we need to make a decision into three separate parts. There's the logic, which will typically be things like rules or decision tables, or it might be procedural logic, or it might be a neural network. So in the example that we looked at, first of all, we have an application is rejected if the applicant is younger than some specified age. Then there's the case data, which is the information about the particular case that we're making, the decision about the applicant's age, for example. And one of the things that's characteristic about case data is it's never going to appear as an explicit value in our logic. It's only ever going to appear as a variable, because it's going to change every time we want to make a decision. Each case is going to be different. The business data is then providing the specific values that are used in the decision-making process, the decision-making logic. So it's things like the value of the minimum age is going to be 18. And business data frequently appears as explicit values in the logic. In fact, if we look at decision tables, it's always there as explicit values. There are certain situations where it may turn up as a variable if we use other sorts of reasoning mechanisms. And finally, once we've actually made the decision, once we've decided our conditions are satisfied, then we're going to have some outputs, and those in general will also depend on business data items. So, for example, the text of the reject reason. So we've got this idea of business data. Now let's think about how we manage it. So if we look at a decision system, then the case data is the input to the system, and it changes for every decision that we make. The logic is the executable part of the system, and that actually is going to typically change fairly slowly. So we might change the minimum age, but the minimum age rule will always be there, and the logic that's associated with it isn't going to change. The business data sits between that in the sense that it's an input to the logic, and it changes periodically. So as a sort of example, which will come up frequently, things like the thresholds for taxes are updated annually in the UK. So there is a periodic change to the business data. Sometimes you may find that business data depends on historical activity. So what the business data that you use in the rules today may depend on things that happened yesterday or earlier on. How do we manage the business data? Well, the first question we need to think about when we're talking about managing the business data is how much have we got? Have we got a half a dozen items, 100, 1,000, more? The examples that we'll be discussing later on, we're talking about tens of thousands, hundreds of thousands of bits of data. So in those sorts of circumstances, our management problem is obviously going to be a lot bigger than if we only have half a dozen items. How often do the items change? If the items don't change very often, then again, our management issues are relatively minimal. If they need to change more rapidly than that, then we're going to have to do some more work. So is there some regular update schedule, like, for example, the tax bands in the UK, or is there a requirement which means that we need to be able to make updates much more quickly? Having to make updates once every 12 months is rather different from saying I need something new in the morning, or I need something new in a few hours, or I need something new in a few minutes. And finally, perhaps the biggest issue, and one which we'll come back to when we'll look at the examples, is where is the source of truth? The business data may be something which is only used within a particular decision service, but more likely it's going to be some information which is shared across the enterprise. So maybe across many decision systems. It may be something which is actually imposed externally. So it actually comes from an external source. And we need to think about where that is and how we manage data which essentially is potentially outside our control. Couple of little observations to make before we start talking about practical examples. Firstly, obviously, the correct execution of a decision service depends on having the correct business data. You've got the wrong business data, you're going to make the wrong decisions. But if you think about the process of actually building a decision service from scratch, and sometimes even when you're going through the maintenance process, you can be reasonably sure that the business data that you had when you started the development process is not going to be the same as the business data when you get to the end, because business data evolves over time. And that means that in a very real sense, while having the correct business data is something you have to have at runtime, having the correct data during the development process is almost irrelevant. You have to have data which is representative, but you don't have to have the right business data. And there are certain circumstances where you may be in a situation where you're developing the system, but you're explicitly told you can't see the real business data. Only the business have access to that. I will leave it to your imagination what sorts of circumstances that might be. Second thing is that it's worth observing that there's an ambiguity with regard to business data when we look at decision tables versus rules. If we have simple standalone rules like the one which I showed you on the first slide, the distinction between the logic, the case data, and the business data is pretty obvious. But if you look at a decision table, the difference between the logic and the business data is not so clear cut. You can ask the question, is a new row in a decision table really new logic, or is it just a new set of business data? Now, you can take both of those perspectives, and there's no, I wouldn't say that sort of one is correct versus the other, but I find taking the second perspective can actually give you some better insights into what's going on when you're building your decision service. So I personally tend to think, certainly initially, as a new row being new business data, not new logic. And the reasoning behind that is simply that the logic of a decision table depends on what columns you have and what types of conditions you permit to go in those columns. It doesn't really depend on the explicit values in the cells. But as I say, you can take the opposite view, and many other people would do that as their default. Okay, that's enough theory. Let's talk a little bit about some examples. Now, I was going to talk about some real world examples of projects that I worked on professionally. I've decided not to do that, basically because I would be going on for far too long. And I'm focusing on some examples which are taken from challenges which have been posed on the decision management website. The reason for doing that is partly that you can actually go and have a look at those on the DMC website, and you can go and see how different people have addressed those problems, and everything's all open. Whereas talking about real world situations, obviously one has to kind of be a little bit secretive about some of the things that are actually going on, like who the clients were and some of the more detailed aspects of them. So the DMC challenges themselves are all derived from real life scenarios, but they've been kind of sanitized. And as I say, you can look at the way that different people have approached them, which makes them good to look at. So the first one we'll talk about is the challenge which was posed about 18 months ago, where we're provided with a big decision table provided as a CSV file. When I say big, I'm talking about something which has got over 16,000 rows, 8 input columns, 3 output columns. So there's getting on towards 200,000 individual bits of business data in that CSV file. The DMC challenge, there were lots of solutions presented to the challenge, and one of the things that's interesting about the way the challenge was viewed is it was posed as a performance challenge. So if I'm given a decision table with lots and lots of rows, how do I get rapid response to actually make, how do I get it to make a decision quickly? Now, looking at that, what you actually find is you look at the various solutions proposed, that the solutions which gave the best performance, there were some based on RETI network type logic. There was a solution which was actually built using directly using hash tables, and there was one which was surprisingly very effective, which was one which was built using Prolog, but they were all kind of fairly clear winners on performance. But one of the things, if you look underneath, is that the challenge actually sort of highlighted many issues that you can get with business decision tables. So one of the ones was, when I first looked at it, the description of the challenge is that effectively the decision table was implemented previously using relational databases and SQL. And so the question immediately that came to mind is actually this the right way of doing it? And quite often when you get these big decision tables, it's because you are essentially getting a legacy implementation, which was somehow done using database tables anyway. And one of the things that one needs to ask oneself is that actually the right way of going about solving the problem? Because you get a lot of baggage with that, and you don't necessarily find mechanisms which might make life business better for the business. Another thing is to ask the question, actually, is performance all that important? When you look at the, again, when you look at the way the challenge is posed, the idea was that we'd be providing solutions as web services. Now, the actual performance that you get depends on your usage pattern. If I ask for the decision table to make one decision, and I'm using a web service, then the network overheads of communication are going to actually be much larger than however long it takes for the decision table to come up with that answer. I need to actually send a lot of decisions to the decision table before I start actually seeing the real performance of the decision table versus the network costs of actually communicating with the web service. So you need to ask yourself, does it actually matter whether my decision table comes back with a solution in a matter of microseconds or a matter of milliseconds? Where should I be spending my time trying to improve performance? Should it be looking at the network usage rather than the decision service itself? And finally, and this is a recurrent question, is how is maintenance supposed to be achieved? When you look at the table, it's about insurance payouts. There are 20 plus different policies embedded within this table. I can't see any way of actually figuring out what's the difference between policy A and policy B. And that's important because when I'm looking at these policies, I want to be thinking from the business perspective, which ones do I sell to my clients? Do I sell them this one or that one? Why would they decide to buy one or the other? So these sorts of questions are quite important. How can we partition up that data so the business can maintain it? And as I say, this is a kind of recurrent theme when you're looking at business data. The second challenge to look at is one which was more recent, posed back in May. Again, it's associated with health insurance. And the idea here is that when a claim is made, then you need to sort of list the diagnoses that are associated with that. And sometimes diagnoses will conflict. So diagnoses are essentially represented using an international standard called ICD, and it's on its 10th version, so it's ICD-10. And these are basically just codes which essentially can be related to very specific diagnoses. And the idea here is that we want to flag up situations where the diagnoses which are being presented conflict with one another. So we're presented with a list of conflicting pairs of codes, and it's quite a big list. I think there are, I can't remember exactly how many items, but it's over 68,000. So there's an awful lot there. And we then have the cases that we're submitting to say, you know, are there any conflicting pairs? And that could be an arbitrary number of codes. The challenge doesn't give you any clue as to how many that should be, but at a guess, I would say it's probably only a few. So I've kind of sort of suggesting perhaps less than 5. And so just to kind of put a bit of meat on that, suppose we have these cases here, where we've been given these sets of diagnoses associated with the case, and we have this this is a sort of subset of our conflicting diagnoses, and we can see immediately that the first case is okay. We have only one conflicting diagnosis with the R42 diagnosis, and there aren't any conflicting diagnoses with R42. Because X52 doesn't conflict with the one that we've got. On the other hand, here in the second case, we can see we're not supposed to have a case where we have V9600 and X52. And if you look a little bit further, you'll actually see there are further conflicts, because X52 also conflicts with W611, and reasonably enough, you'd expect some sort of transitive effect. You don't get the V96 as well. And the final case, really just to make the point that when you get the cases, there's no reason to assume the case data, there's no reason to assume that the diagnoses are in a particular order. And certainly in terms of the the list of conflicting pairs. The cases, the conflicting pair codes aren't in any particular sort of order. Right. I was told I should put a joke in, so here is some light amusement. The ICD code 10 codes are comprehensive. They cover any kind of diagnosis really that you could imagine. So there's W5521, which is the diagnosis that you were bitten by a cow, which seems a little bit improbable, but it's not as bad as W6112, where the diagnosis was that you were struck by a macaw. Now, the next one, V9733, I don't think this is a real diagnosis, because I don't think you can survive this. That's been sucked into a jet engine. But the most incredible diagnosis that I have seen so far, and I dare say this is not the most bizarre, but V9107 is that you have been burnt due to your water skis being on fire. Like I said, the IDC 10 codes are comprehensive. Right, that's enough fun. Let's get back to managing these conflicting diagnoses. And the basic logic that is involved is really fairly simple. We can see that what we need to do is we need to generate each possible pair of diagnosis codes from the case. And then we just need to see for each of those pairings if that pairing is among our list of forbidden combinations, and just report any forbidden combinations. And if there are some, there's a problem with the claim, and we can tell people what the problem is. So what we're doing here is we're combining some procedural logic which generates the pairs, and then some declarative logic for actually testing it. And we need a very efficient search of the forbidden pairings because we've got so many of them. But if you think about it, all we're really now doing, once we've got to this stage in proceedings, is we're just doing a lookup. So all we need is basically to have a mechanism for looking up to see whether this entry is in the table. So logically, the problem is actually fairly basic, and you can come up with a solution which is very highly performant quite easily. But maintaining the business data is something which is a completely different kettle of fish. And this leads us on to the sort of idea that when we're building decision services and we have this business data, we may be dealing with third-party data. And third-party in this situation is really we're just talking about data which is outside the control of the team who are maintaining the decision system. They belong either to the enterprise generally, and it's shared across the enterprise. So the decision system, the decision system team don't own it themselves, or it may be something which actually comes from a completely external environment. So it's imposed by some regulatory body. And here, for this particular example, high performance utilization of the list is something which is really quite an easy thing to do. The solutions which have been posted on the DMC site are really the performance of those systems is independent pretty much of the size of the list. The performance wouldn't change a great deal if we only had 7,000 pairs of conflicting diagnoses, or if we had 700,000. It's not really kind of not really dependent on those sorts of things. But maintaining this data is not going to be particularly simple. As I said, the IDC 10 codes are comprehensive. That's because there's over 70,000 of them. And this is the number that's in use in the USA for 2002. Clearly, nobody understands all of those 72,000 codes. They're only going to understand some subset of that. And if we're going to try and maintain this list that we have, then to add or remove or modify items from that, then you're going to have some clinician who can understand the diagnoses and how they conflict. And Medical diagnoses are not straightforward sorts of things. They don't kind of neatly fall into silos. A diagnosis may be something which is relevant to a cardiologist or an oncologist or a renal specialist. It's going to be something which you can't just kind of silo everything into, you know, this is for you cardiologists, this is for you neurologists, this is for you hematologists. It's just not going to work. And these are typical issues where you've got lots and lots of business data. It's difficult to actually kind of break it down into simple groups, and the maintenance problem is challenging. And you may end up in scenarios where you actually need more effort in designing tools to maintain the data than there are to use it. Now, that's actually an opportunity as far as decision management community is concerned, because a lot of those tools actually would benefit from having decision management services built into those to help them actually help the business actually maintain the data. And I think there is there's a market there which perhaps is not being exploited the way it could be. And then just to go back and revisit this idea of the source of truth. So if the development team doesn't own the business data, the decision system, and this is actually very common, particularly if there's lots and lots of business data, the decision system isn't the source of truth. Somebody else owns the source of truth. And so what you need then is to be sure that the business data which is actually used by the decision system is the correct business data. It corresponds to what is the current source of truth. And how do we actually go about making sure that that's the case? Well, we have a number of options. One option is to go through comprehensive testing processes. And that is actually a viable option if you're not talking about huge amounts of business data and you're working within an environment where the changes are relatively infrequent and they're scheduled. And so I've worked with financial services companies who have sort of schedules to say, okay, well, the UK tax band is going to change at the end of financial year. We're going to make that change and we're going to incorporate it with some other changes. We're going to do comprehensive retests of the entire system. And in those sorts of scenarios, that's a perfectly viable approach for going for things. A second approach that one can take is to start using code generation mechanisms to build from the source of truth. And to take an explicit example of that, the Drools rules engine actually implements decision tables by consuming Excel spreadsheets. So you build an Excel spreadsheet, and then when you tell the Drools rules engine to compile the decision service, it will read in that Excel spreadsheet and build from it an executable piece of code. So all you need to do then is basically have a relatively simple technique for generating your Excel spreadsheet from the source of truth, which is actually it's a sort of thing that is fairly straightforward. And indeed, your Excel's quite often you'll find that business actually have the source of truth stuffed away in an Excel spreadsheet to start with. A third option is to directly consume from the source of truth. So postcode risk factors is from a slide which I had to remove because I was going on for too long. But in this situation, we're actually kind of building the decision table by directly consuming some data from data analytics, and in the IDC 10 example, one of the solutions directly reads the CSV file which are presented as being the source of truth in order to actually kind of build a decision service as well. So there are a number of challenges which are being presented to us by having lots of business data. There are options in terms of how we manage them. And one of the things here is where we have very large amounts of business data, the sorts of logic that's associated with them, be it business rules or procedural logic or decision tables, actually generally tends to be very simple. And it's very simple simply because if it were complicated, we've got huge amounts of data and huge amounts of logic. Nobody's going to be able to figure out what's going on at all. Now, sorry, I'm being interrupted by telephone calls. Another topic which I'd like to kind of touch on, this is something I can't really kind of go into as much detail as I would like to, but it's one of my kind of hobby horses, is looking at complex business data. Now, sometimes business data is just simple facts. So it might be the minimum age for an applicant, or it might be the loan to income ratio for affordability. It's just little numbers. You know, the management issues associated with those are relatively trivial. But usually business data is not sort of comprising of simple facts at all. Usually, well, in an awful lot of cases, it turns up in the form of tables. So you have multiple rows and multiple columns. And things like the tax bands and thresholds and rates, which I keep talking about, are one example of that. That is very common, I think, because the way that business have been, you know, sort of building up their data for many years is by stuffing it into relational databases, and so the data turns up in the form of tables. It's not kind of particularly complicated sort of sequence of events. Sometimes you'll get rather more complex structures. So you'll get nested tables. Sometimes you start getting things like trees and graphs for more interesting and more complicated decision-making processes. Now, tables of business data often translate very neatly into decision tables. But that's not always the case. And so the final DMC challenge, which I'd like to kind of look at and sort of discuss some of the aspects of, is one which was posed a few years ago, which is about order promotions. Now, the idea here is how do we apply promotions and discounts on some imaginary online store selling some imaginary goods to imaginary customers. And one of the features about decision management community challenges in general is that they are very open-ended. So you can kind of decide what it is that the challenge is really asking you to do and go away and do that. And other people will decide different things and go away and do different things. This one was perhaps more open-ended than I think than any of the others, because it basically sort of said, well, you need to manage these promotions and discounts. But it only gave one example of what a promotion might be, which would be that we'd reduce the cost of an order if it contained a certain number of items of one kind and a certain number of items of another kind. And as soon as you look at that, you start asking questions. So there is a technical question, which is something which actually doesn't come up immediately. It comes up 5 minutes after you've actually started trying to implement the solution, which is that there's a dependency between the type of item and the quantity. And the reason why that's a problem is because if you think about a simple decision table implementation of it, I can kind of say, okay, does an order contain a particular item? But then if I have a quantity associated with that, how do I actually say, well, I'm interested in that quantity of that item? All I've established so far is that there's an item on the list. So there's a dependency between columns there that causes an issue. But there are also other sorts of questions which come in. Suppose rather than ordering 5 items of 1108 and 4 of 2639, I order 10 of 1108 and 9 items of 2639. Do I get a discount of $7, double $3.50, or do I only get $3.50? Because if I'd made two separate orders, I'd have got two separate discounts. So, you know, are there some sorts of mechanisms by which you get accumulations? And so one of the problems is that decision tables struggle with this idea of independent columns where I have both an item and a quantity. And there are ways around that. I mean, one way around that is to use enhanced cells. So if you're using suitable implementations of decision tables, I can have cells which don't have one value in, but have multiple values in. Or I can use multiple decision tables which are linked together, which essentially capture both of the items. But then we start having other sorts of issues, like, well, what happens if we have promotions where the items are shared? So I have a promotion on if you buy item A and item B, there's a promotion. And if you buy item A and if you buy item C, there's a promotion. So if I have these promotions, do I use all of them, or do I just use one? And if I use one, which one do I use, or does something else happen? And other issues which I must admit that this when I was looking at this, it never even occurred to me. But one of the other challenges, one of the other solutions pointed out that if you want to have order promotions, you want to make them visible to the users, the people who are buying the goods, because if they don't know about the promotions, they're not going to try and make use of it. And the whole point about promotions is not that they save the customer money, but that they encourage the customer to spend more money. Promotions are not about, from the perspective of the retail, are not about giving money to the customer. They're about persuading the customer to spend more money. If you have a promotion, the promotion is about increasing your sales. It's not about giving discounts to the customer. And if you don't let the customer know about the promotions, then they're not going to use them. So promotions are about increasing sales. They're not giveaways. Customers who don't know about them aren't going to exploit them. So there are there are different ways of going about doing this, but one thing that you might want to do is essentially identify the different sorts of promotions. So there are promotions which are always applicable. As soon as you hit the simple criteria, then you apply it. There are promotions which conflict. So you may hit the criteria for multiple promotions, but you have to then essentially decide which of those you're going to make use of. And then there are things like accumulative versus one-off promotions. So a one-off promotion would be, say, if you meet this condition, you get this fixed amount of money off your order. Whereas accumulative ones say the more of this you order, the more discount you get. And if you order, substantially large quantities, you get better discounts per unit than you do if you only make smaller orders. And the list of different sorts of promotions you can go on, it really is limited to your imagination. There's all sorts of things that you could do. So trying to do this sort of thing fully with all of the business data hidden within the decision service starts looking very difficult. It looks much nicer if you can try and define the promotions externally. The big advantage of that is that you can much more easily show to customers what's going on. If you have your promotions hidden away in a decision table or in a set of rules, how can you be sure that you can show those things to the customer? Whereas if you define your promotions externally, then you can just show those to the customer as well as building them into your decision service. And it also certainly from a real life case of a business which was doing something which is very similar to order promotions. The business really wants to have the promotions defined externally so that they could maintain and update the promotions separately from the logic. And then you can import the promotions either on a case-by-case basis or periodically to make sure everything is up to date. And what you're doing here is by defining the promotions externally and not being sort of specific about what the actual logic is, just essentially being able to select different bits of logic, you can make a combination of rules and objects and procedural logic to fit in with all the different kind of logical promotions you can have, and also build in strategies for choosing which the best promotions are to apply. So to get to some sorts of conclusions, so the business data is essentially embodying the current objectives of the business, and typically when those objectives change, rather than the first port of call being to start going in and changing the logic of the decision services, it will be to modify and update the business data. It changes far more frequently than the business logic. And there are multiple different ways of managing the business data. But when you're thinking about managing it, you need to be conscious of where the source of truth is. So is the source of truth owned by the decision service itself, or is it external? Where there's lots of business data, you'll generally find that the rules that are managing that large amount of business data are very simple. So the real problem with lots of business data is actually the maintenance of the data, because nobody is going to understand all of that data. Nobody understands that list of 70,000 conflicting pairs. They will understand some subsets of it, but they can't get their head around all of it. The big decision table with 60,000 rows and 8 columns, input columns and 3 output columns. Nobody understands all of those rows, but they will understand subsets of it. Externalizing the business data so it's not embedded within the decision service can help both management from a management perspective and from a performance perspective. For very simple data structures, rather than using something like an engine for executing decision tables or an engine for executing rules, you can use very simple basic data structures like maps and sets, which will give you very high performance and can consume the external data very quickly and allow you to focus on the more complex logic using more sophisticated tools. Simple or complex code generation tactics are available for doing things straightforward for importing this data either directly or using code generation mechanisms. And finally, and this, as I say, this is one of the bees I have in my bonnet, is a lot of complex problems can be simplified using object-oriented techniques rather than trying to treat the business data as being very simple data items. And that leads us on to issues where we ought to be able to consider whether or not using a combination of objects and rules can give us significant advantages over using straightforward decision tables. Okay, well, I actually seem to have finished a little bit quicker than I usually do when I practice this, but if there are any questions, I would be pleased to try and answer them.
Great. Thanks for that, Bob. That was really interesting. And I actually looked at your slide deck, and I see you have some other examples at the end that are interesting as well. Jacob had a comment more than a question, but he said that sometimes an order might be eligible for multiple promotions, but you have some other sort of constraint that says the total discount can't be more than 15% of the order's cost. And then you need to look at a not necessarily a rules engine, but an optimization engine. Do you have any thoughts about that?
No, I agree entirely. I mean, as I said, when I was sort of introducing the challenge itself, I mean, it is incredibly open-ended, and there are an awful lot of techniques that you can use for what you would do with promotions, and the sorts of schemes that you can come up with are almost unbounded. I mean, your problem is not sort of what the ingenuity of people is basically trying to kind of persuade people that they need to have some limits on what they're doing. I mean, there is an associated project which as I say is a real life one, where we were looking at it wasn't actually promotions, but it's remuneration schemes, and the client offered, I think, a dozen different completely differently working remuneration schemes, some of which were so complicated that you could see that they were clearly struggling to actually explain how they worked. And
it goes back to the discussion we were having during Alan's presentation about just, is the problem maybe explaining the decisions, not necessarily codifying them once you have them explained?
Yeah, well, I mean, this was explaining how we were supposed to build the solution to it. Yeah, I mean, there's lots of different ways that you can do it, and I think the point really about complex business data is that one needs to kind of be imaginative about what kind of technologies and techniques one uses to apply to them. And certainly sticking in something like an optimization engine might be one thing that you do.
Okay, good. I'm not seeing any other questions right now, but if anybody does have one, you can put it on the Slack channel, and I'm sure that Bob will check in on there later and see what we have.
Just to reply to Carol Ann's comment. Yes, I entirely agree. I mean, the only reason why I used rules as a specific example was because the last time I did something like this, I was using rules. But I'm well aware that that there are plenty of other engines that will do the same thing.
For those of you who haven't been watching Slack, it's Carol Ann had said she didn't know of any rules engine that didn't consume data from a spreadsheet. So she just was pointing out that Jules was not unique when Bob was talking about doing that.
There is another comment from Alan. Question.
I think that's it. So
no, there is another question.
Yeah.
Okay.
Okay. Right.
Oh, sorry. I didn't even see that. It just popped up. Yes.
I mean, the issue about importing the data at execution time, I mean, normally the way that you'd do that would be you'd cache the data, so there is an overhead in loading it, but you wouldn't want to do that on every case. And I mean, you can manage those sorts of things relatively simply, either by setting a flag on the data to indicate that it's stale. So when you do an update, you basically set the flag to say, you need to reload that, or you can do a periodic refresh. I mean, I built a number of systems where basically it would kind of be running, and after some set time period, which might be an hour or 24 hours, whatever was appropriate, it basically just say, well, we'll flush the data and we'll reload things. But that was relatively unsophisticated, because it's much easier if you actually can kind of set a flag to say, the data has changed, and then you can periodically check the flag to see whether things have changed. And it depends on what you feel your sensitivity is on things. So you can send direct signals. If you're using something like a web service, you can send a direct signal to it to, it needs to rebuild the data structure. So there aren't particular performance issues associated with that, because most of the time you're reading directly from the cache, which gives you typically microsecond performance.
Right. So if you need to have some way to indicate that your data is stale, then yes, a signal or something could be the way to do that. So then you just refresh it at that time. Otherwise, you could get into computational loads or delays just if you're going.
Yeah, I mean, if you're dealing with, I mean, the one of the additional examples I was talking about was basically doing risk rating through postcodes. Now, postcodes in the UK, there are 1.8 million, and so doing if you were doing that as a decision table, that would be a decision table with 1.8 million rows in, so that was actually implemented as a simple Java hash table, and it's incorporated into a system which had got hundreds of rules and several decision tables. But for that particular thing, you want to be able to do that very quickly. So the performance in terms of doing the risk lookup was, as I say, microseconds, but to have implemented it using different technology would have been significantly more expensive.
Okay, just time for one last question, and then we do have to go. Hans had a question there about how does this business data import go hand in hand with having rules available that apply to, for example, a different era of data, like when you have legislation change. Is capturing it fixed in the rules not the only way to go then?
Yeah, I mean, the issue about managing historical data is, I think, something rather orthogonal to this, because there are a whole raft of big issues associated with trying to manage historical data, and basically be able to say what were the rules 6 months ago, or what were the rules 2 years ago, and trying to basically reproduce decisions made on those sorts of bases. So it's a very valid issue, but I think that it's not actually particularly relevant in terms of this, the idea of the data of the data import, because it is a universal issue that you have with decision services, that it's very difficult to manage, kind of how do I go back to a previous version and run the logic against a previous version of the rules.
Right.
And if you need to be able to do that, then you basically need to be able to recreate the whole of that environment. And certainly if you're sticking the data into something like a database, I mean, if you make it a version database, then it's perfectly possible to do that. But it is a real issue.
Mm-hmm. Well, we look at that with, like, again, like, I'm from the process side more than the decision side, but long running processes, if we have a process that is running potentially over months or even years, and it needs to have a rule that is either, well, okay, I'm calling because I need to make a decision and use the current version of the rules, versus I'm calling and I need to use the rule that was in effect at the time that this process was instantiated, which could be 12 months ago. So there's that ability to, how can we recreate that same decision in time, depending on the requirements.
Yeah, I mean, it's a very serious problem, but I think it's the topic of another talk.
Yeah, exactly. Okay, so there are a few more comments over in the Slack channel, but I think we need to kind of get cut off now and get ready for the next presentation. So thanks very much, Bob, and we're going to get set up with Seth now. So we'll have about a 5-minute break, and we'll see you back here at the top of the hour.
Okay, thanks. Bye.